Alright, so for this video, we're going to learn how to code a basic driver control. Now, we're just going to use a regular clawbot here. So that means we're going to have a two-wheel drive and we'll do one motor for the arm and one motor for the claw. So this is just like a sample bot that we're going to use, and we're going to code for it. So if you want to make a user control, you'll launch your code, obviously. If you've watched the last video, you'll know how to do that through examples and then doing a competition template. So that's what I'm using right here. It's the competition template. And if we want to do our user control, we're going to scroll down to where it says void user control void. So all the stuff we're going to put in our user control has to be inside of these brackets right here. If it's not inside of that, it won't run, and you'll get a bunch of errors. So that's super important. Some other things to note: these green things here are all comments, which means that they'll be ignored when the computer compiles the code. These are useful for writing actual text, so you know what is what. I recommend that you comment often so that you know what you're doing, because especially once your code gets large, it can be difficult to remember what this part does and like what part it's related to and everything like that. So it's just always a good idea to format your code well, and you'll see some examples of that as I do that. So inside of the user control right here is we have a while loop. And while one just basically means that it's going to loop forever. So the reason why this is here is because the driver control is constantly checking whether you're pressing a button or moving a joystick, and then it'll send that control to a motor. But it always has to check for that constantly. So that's why it's looping here. And you'll see at the bottom there's a little wait for 20 milliseconds. That's just so that we can save resources, because we don't want it like updating like millions of times per second, because that's just a waste of computer power, and you won't really notice a difference. If you're especially prone to latency, you can probably turn this down to something around the range of 5 or 3 milliseconds. But I would at least have something here, just so you're not wasting resources. So let's get to it, I guess. So to start off, the first thing we got to do is add all of the motors and controllers we're going to use. So we'll go up here to this motor icon, and you see I've already added a controller. We're going to delete this motor real quick, and then we're going to add our 4 motors that we need for our clawbot. So we're going to add the first motor and the first port. We'll name it left drive, and then it's going to be a medium motor. We'll have it as normal. And then we're going to add our right motor, port 2, right drive. This one's going to be reversed because it's mounted on the opposite side. So that way when we write forward for both of these motors, it'll go forward instead of turning in a circle. So always remember to do that with your left and right motors. For the arm, we'll do port 3. This one, for the sake of showing you guys, I'm going to use a torque motor. And then actually we'll rename that to arm motor. And then we'll do the claw motor. Alright, so now that we've added all of these motors, we can now use them inside of the code. And you can always check what motors you have by either opening this over here and seeing them on the side, or you can scroll up and there will be a section over here that says Start VEXcode Configured Devices. And this will comment in all of the motors, controllers, and sensors that you have. So just in case, like, for whatever reason this isn't showing up here, you can always look here and it'll be there. Alright, so we're going to go over to our user control section right here. We're going to delete all of these comments because we don't really need them anymore. And then we're going to write left drive, which is our left motor, dot spin, and then we're going to do the direction, which is forward, comma, and here is where we do the power. So for right now, we'll just say 100, and then the power type that it wants. We have a couple of choices, but right now I'm just going to use PCT, which is %. And then we're going to end that with a semicolon. The semicolon is important because you need that after every statement that you write in C++. So if you don't have those, it's not going to compile, and then you're going to be wondering, like, oh, why isn't my code working? But it's really just because you left out a bunch of semicolons. So what this is essentially saying is to start the motor left drive and spin it forward at 100% power, right? And we can change all of these values. So say we want it to go backwards, we can do reverse. Say we want it to run at 50% power. Say we don't want to do percentage, we want to do RPM. So now it'll run at 50 RPM. And if you want to use rotations per minute, a good thing to keep in mind is that different gear cartridges will work at different RPM percentages. Or, yes. So the green motor, which is the medium one, has a max rotations per minute of 200. Torque motors have a max rotations per minute of 100, and the speed motors have a max rotations per minute of 600. So it won't go higher than that for each of the motors. But for now, just for simplicity, since we're using two different types, we'll just use percentage. Alright, so now how do we take this and have it so that when you press a button on the controller or press a joystick, that it'll move, but it won't move any other time? So there are a couple ways of doing this, and then we're going to go through some of them right now. So one way, if we want to use just a button, let's say, what if we want to use the arrow button right here to spin the left motor forwards? We'll do if controller1 dot, and then we have all the buttons here. So let's see, button up. So that's this one right here. Controller1 dot button up dot pressing. So this is saying if controller 1's button up is pressing, if that's true, then it'll start this statement. If it's not, it won't do anything. So this is the most simple control you can do, pretty much. It's just an if statement and then a statement underneath that's telling the motor to drive forwards. But let's say, all right, we don't want just the left motor to go forward. We want both of the motors to go forward when we press the button. So what we got to do, we'll copy this, paste it over here, and instead of doing left drive, we'll do right drive. But the problem here is that the if statement only goes down one line, so it'll only drive this left one, and the right drive will do it all the time because it's only part of the while loop and it's not part of the if statement. So if we want to include both of these in the if statement, we got to add brackets. So we'll do one at the beginning and then one at the end. So here you can see the start brackets over here and the end brackets over here, and it's encompassing both of the commands. So now they're both tied to the if statement. So if we press button up, both of those will spin. If we don't, they won't. So now let's say you've implemented this, and it's all good, right? You're pressing the up button and it's going forward, and when you don't press it, it stops moving. But when it stops moving, it kind of coasts for a while. It doesn't stop right away because the robot still has momentum. So if you want it to brake when you're not pressing the up button, you got to add another statement. So if the controller button up is pressing, then it'll do that. But when it's not, or else, we'll have it brake. So if we want it to brake, we can do the motor name again, left drive, and this time we'll do dot it's dot brake, I believe, or dot stop. Sorry, dot stop. So left drive dot stop, and then we gotta specify what type of braking motion we want it to do. So normally you'll just use brake and add the semicolon at the end. There are other types, like there is also coast, if you wanted to do that, which basically means that it'll do what it was doing before, where it'll spin and then stop the motors, but it won't actually actively brake it. If you do brake, this is usually what you want, is where the motor will actively try to stop the axle. And then the last one is hold, where the motor will actually use its built-in encoder to figure out when it was stopped and kind of move back to it if it moves forward from that. But for driver control, you'll just want to use brake. Also, if you've implemented this, make sure that whenever you're moving your robot, you're not like moving the wheels around on the field while it's braked, because that puts unnecessary strain on the motors, and it's just not good for the hardware in general. So always make sure you pick up your robot and set it down when you're moving it somewhere. And then if we want both motors to do that, we just gotta add another statement and make this right drive. So this is good if you want to drive forward. It drives forward when you press the button, and it stops when you're not. But if you want to add motion like going backwards or turning right and left, you want to make sure that if you're pressing more than one button at once, it's only going to do one action. Otherwise, you can kind of run into some weirdness. So a good way to do this is putting the statements in else-if statements. So here, if we want it to go backwards, we'll copy this and do button down instead. So we'll copy this as well and change these to reverse. So now the program will check, okay, is button up pressing? And if you're not pressing button up, it'll go to this statement. And if you're pressing down, it'll do this one instead of the first one because it's checking for the buttons. Now do keep in mind it does go in order of what you're doing. So if you're pressing like the up and bottom buttons at the same time, it'll go forward because it is checking for the forward button first. So just something to keep in mind. And we can also do this with turning. So we can just copy this whole thing, and then you can say if we want to use button left. Turning, do that, and then button right, or turning the other way. And then this one, if we're going to turn left, you have to make sure that left drive is going reverse, and right drive is going forward. And then the opposite for going right. Alright, so we have this now, and it goes in all four directions. So it turns, and it goes forward, it goes backwards. But it only uses the buttons. And I know a lot of people are used to moving around with the joystick, and it's a lot easier to do it that way. At least from the driver's perspective. So if we want to drive with the joysticks, there are a couple ways to do it. There's tank controls where you can move, when you move the left joystick forward, you move the left wheel, and when you move the right joystick forward, you move the right wheel. I don't really recommend this. It's often much harder to drive using it as opposed to, I believe it's called arcade control, where all the lateral motion is tied to one joystick. So both motors would be moving forward when you move the joystick forward. So I'm still going to show you how to do both methods, but I definitely prefer arcade control. So if we want to code arcade control, we don't really have to change too much here. We'll have to change the button to the joystick, however. So we'll, instead of doing button pressing, we'll do axis 3, which is the forward and backward axis on the left joystick. So axis 3 dot position, and in here we'll do %. So this is saying if the control axis position is at a certain percentage, we also have to add a thing that says if it's greater than 0. So this is saying if the controller joystick value is greater than 0, aka when we push it forward, it'll run this code. So this is not an analog stick right now. So how we have it set it up is basically it's either a 0 or a 1 value. If you're not pressing it, it's not going to move. If you're pressing it, it's going to go full tilt, 100% at the motors. But usually you want an analog stick where you have more control over the speed. So you can push it a little bit to go a smaller amount of speed, and then a large amount to go at full tilt. So to do that, all we got to do is copy this right here and replace 100 with it. And what this will do is, this is a variable. So a variable is basically like when you do algebra, it would be the x. So it would be, so the controller is always feeding the value to this variable right here. So if you're not moving it, the variable will be 0. If you're moving it, if you have it all the way, the variable will be 100. So we can use that as the motor percentage. So that way you get smooth analog control whenever you're driving your robot. And we can do this for the other ones as well. So we're just going to copy this. Actually, what we can do to make this even simpler, actually, is we don't even need this reverse one at all. So we can just get rid of it, and then all we got to do is change this to does not equal 0. So basically what happens here is that it's checking that the axis is not 0, so it's moving either forward or backwards, or your joystick is moving either forward or backwards. And then if it's moving backwards, this value will be negative, so it'll move backwards. Even though it says forward here, that's just for the direction. So if it's negative on the value, it will still move backwards. And the forward and reverse is just reversing like the polarity, I guess. So if this is a negative, if this value right here is a negative and this is reverse, it would go forward instead. That might be a little bit confusing, but it's just a bit of a quirk. And then if we want to do turning, all we got to do is take this axis position again, and then replace it here. And then make sure that since we are using a different axis for turning, which would be, we'll use 1 in this case, so we'll do it on a different joystick, because sometimes what can happen is, especially if you're segmenting the controls like this, if you have the turning and going forward on the same axis, if you have the joystick going to the left or to the right, even just a little bit, it might do the turning code instead of the going forward code, and it can kind of mess up your driving. So we're gonna do this on axis 1, just so we don't have to deal with that. And here, if it's going to the right, it will be positive. So we're gonna make this, reverse this real quick. And then all we gotta do is add this and replace 100 with it, and now you have analog turning as well, and you don't need this anymore. So that is how you set up analog arcade control. Now, if you want to set up tank controls, where you have each joystick controlling a specific motor, all you have to do really is just change the variable for a different axis. So this one would be axis 2 instead. And then here, make sure that you also check for both, because what might happen here is if you want to move the right joystick only, what might happen is, because you're not checking if the right joystick is moving, it won't move because it is only checking for the third axis, and it won't run this code even though this one's only dependent on the second axis here. So what we can do to that is do 2 of this symbol. I'm not really sure what this is called, but 2 of those means OR. And then we are going to copy controller axis 2, and then do does not equal. That's the symbol for does not equal, by the way, 0. And then we can get rid of this, because with tank controls, you turn just by moving the joysticks in opposite directions. And then all we have is this left. So the main reason why people do tank controls is usually it's easier to code, because as you can see right here, we only need like one statement to do it. But yeah, like I said, it's just really up to your preference, what you prefer to drive with. So yeah. So I reverted back to the arcade analog controls, just because that's what I would recommend using, and that's what our team uses on our robot. So we've got our driving down, right? But we still have to add our arm and claw motors, because those are separate motors, and what we need to have happen is those need to be able to run at the same time as we're driving. Because if we are like going up to a tower, we want to be able to like raise the arm and drive towards the tower at the same time. Because if we can't do that, it's a big time waster. So we can't really do that right now, because in this if-else block, it can only choose one of these statements to run in one cycle. So to combat this, to be able to run 2 motors at once, we got to add another if statement that's separate from the other ones. So this, so what will happen in this cycle is it'll choose one block from this state, from this area right here, and then it'll choose one block from this area right here. So that way we can run multiple motors at once. So let's say we want to use the right triggers for moving the arm up and down. So we can do controller 1 dot button R1. And this is gonna pressing, and this is gonna move our arm motor up. So all we gotta do is remember that that's our arm motor. Do arm motor dot spin forward 100%. So this one's a torque motor, so since we're using percentage, it'll just take the percentage of whatever max RPM it can run at and do that. If we were to use RPM, then we would have to make sure that it's not 200, it's only 100. But since we're using percent, we don't have to worry about that. And then we can do the same thing that we were doing with buttons before, which is just an else if statement for moving downwards, part 2, and then do this, reverse. And then a final else statement that just breaks the motor if it's not doing anything. And then we can do the same thing for the claw. So if we were to, let's say, use button, like button A and B for opening and closing the claw, we can just copy the stuff we've already made, and then do button A, and then claw motor, button B, make sure this is claw motor as well, and then claw motor. And now you can both drive with the joysticks, you can move the arm up and down and open or close the claw all at the same time. So this is essentially going to be the basics of your user control. So everything's in a while statement, and for different actions that use the same motors, you're going to use an if-else statement block, and then with checks for the buttons you want to use. So yeah, that basically concludes. Oh, actually, an important thing to do that I mentioned earlier in the video is comment what each of these things are doing, because if you're kind of just staring at this and realizing like, wow, I don't remember what like this right here does, comments can help alleviate that. So something simple we can just do is say that this is the driving code, and then this is the arm code, and then this is the claw code. And then you can make single line comments just by using 2 slashes right here. And if you want to, for example, comment out an entire section, for example, if you want to just try a certain part of the code and you don't want to delete another part of it, but you don't want it to run, you just do /*, and then at the end of the selection you want to comment, you do */, and this entire area will be commented out without you having to go through every line and doing this //. Yeah, so that's about it. That's how you make a basic driver control. If you have any questions, just leave them in the comments below, or talk to one of the people in our robotics team who knows how to code. We do also have a Discord that you can join if you would like that as well, so I'll link that in the description of this video. Yeah, that's about it. Good luck.